everyone. Today I'm going to explain about the k-means clustering, how we can use this algorithm in our dataset. Generally, the k-means clustering is an unsupervised machine learning algorithm. It means it does not require the label for the training or testing. We just provided the datasets, and this algorithm is used for the partitioning a dataset into k distinct clusters, that is the number of the cluster that we want, and it is generally used for the data mining, pattern recognition, and the image segmentation. Now let us use these algorithms for our datasets. Here I have already executed my code in order to make the video short and simple. First, I'm importing this library, that is the NumPy library, as NP in order to convert my dataset into the NumPy array form for the smooth training. Next is the Matplotlib library. Then this library is used to visualize our results. For example, in the form of pie chart, bar chart, or graph, we use the Matplotlib library. And I have imported this NumPy as NP and this Matplotlib library as PLT. Next, we are not uh, designing a k-means algorithm from the scratch, but we are importing this library from this sklearn. So from this sklearn, I have imported the k-means algorithms. And here in this line of code, here I will execute this. Here these data points are my data sets, my data points. Let this first one, the x value is the feature 1, and y value is my feature 2. So I am trying to apply the k-means algorithms in my data sets. Now first what I will do is I will convert my data sets into the NumPy array form by using this NumPy for the smooth training. For this I will write the code np.array. What I want to convert into the array, my data, that is whatever the data set I'm having, I'm converting it into the NumPy array form and storing it in the variable x. Now x contains my data sets of NumPy array form. Now next is in order to create a k-means clustering, we have to specify the number of the cluster in advance. Therefore, I am specifying k equal to 3. That means I want 3 clusters for this datasets. So I am specifying the value of the k equal to 3. And here, since I am not designing this case from the scratch, I am importing it from the sklearn. So I have written here k means here, and I have specified the number of the cluster should be k. The number of the clusters should be k, that is the cluster. Here k specifies the number of the cluster that needs to be generated. Next is the random state equal to 42. What does this mean? It means how many times, the number of times I will execute my program, the output, the number of the cluster generated should not change. It will always remain the same. Therefore, to fix the output, we are setting the value of the random state equal to 42. In generally, while training the machine learning and deep learning model, we want the output to remain the same, constant. Doesn't matter how many times we execute our program. Therefore, to fix the output, we have to set the value of the random state equal to 48. And here n in equal to 100, it means the number of iterations that will be used to train these algorithms. For example, I am training my k-means algorithms for 100 iteration in this data points. For it will iterate it 1, again it will iterate all the data points 2. This keeps on going. Let us make it short. I'm just writing here this number of iterations should be 10. It means my k-means clustering should get trained at these data points only with the 10 iteration. Only it should have make the 10 iteration on these data sets. Now, once this model, this k-means is trained, I'm storing my model in the form in the name of k-means. My model name will be k-means, and I'm training this k-means model with with the function fit. Generally, fit function is used to train the machine learning and deep learning models. And here I am passing only the data set, that is the x. I am not passing the its label, because k-means clustering is an unsupervised algorithm and we do not require any label. We only require the data sets. So I am only, therefore I am specifying only x here. If I will write here x comma y, it means here y represents the label, but since k-means is unsupervised algorithm, therefore we don't provide the label. I'm just writing k-means dot fit equal to x. Next I will execute this code. Now this code has been executing, and here this line of the code, now my this here my this k-means model is being trained with 10 iterations on the dataset x. And once this k-means model is trained, I will fetch the value of the labels as well as the value of the cluster centers and store it in the labels, and I will store the value of the cluster centroid in centroids variable. Now in order to visualize my label and centroids, I'll be using matplot library. Here this is the matplot library plt. I have imported the matplot library using the plt as plt. So I'm using this plt dot figure size equal to 8 comma 6. Here 8 represents the width of my windows of my figure. It means it is 8 inch and height is 6 inch. Width is 8 inch and height is 6 inch. Now next I am also plotting the first features, that is the 0 x1, and next feature y feature. I specify with 1, and next here is equal to labels, and the color map it should be generated in Bardish quality. It is CMap this represent Bardish represent the color map. For example, RGB is there, BR is there, and Bardish is also there. So I am generating this my color format in this Bardish form. Next I am specifying alpha equal to 0.60. It means generally the value of the alpha lies in the range 0 and 1. Alpha equal to 0 means whatever the my data points has been plotted will be in transparent form. If I set the value of alpha equal to 1, it means my data points will be visible in very dark form. Yeah, it means it in opaque forms. And if I set 0.60, it means the data points will be visible moderately, neither too much opaque, neither too much transparent. Next is to plot the centroids. I am also plotting the centroids of feature 1 and feature 2. And it should be plotted in the green color with marker x, and s equal to 200 represents the size of the centroids. For example, I am choosing 200, it means it is a moderate size. If I choose bigger value, my centroid will be bigger in size, and this is the label. Similarly, to plot this title, I am using plt.title, and this title is k-means clustering example. K-means clustering example. And similarly, to plot the x label, I will be using plt.xLabel, and to plot the y label I will be using plt.ylabel. Now from using this code, I will just display whatever the information I have provided here, plt.legend, plt.show. Now I will show the execution of this code. Now you can see here this graph has been plotted. These data point are these yellow, this purple color are these are my the data points that has been plotted with the these settings. If I set the value to 0, let's